Hello viewers, you're welcome once again. We are still under logic, cried Almighty God's algebra. Today we are going to treat law of identity. A law of identity, a law of identity by conjunctive statement, law of identity by disjunctive statement. We are going to start with law of identity by conjunctive statement. Let us start. Law of identity. P and T is equal to P. This is an example of law of identity by conjunctive statement. By conjunctive statement. Why do we call it law of identity by conjunctive statement? Is because of this and conjunctive that combines P and T together as a compound statement. And this P and T is equal to P. That's why it is called law of identity by conjunctive statement. Let us prove this statement that it is true. Proof suppose P and T is equal to P. We assume that the statement is true, that P and T is equal to P. If you look at this statement, you will find out that it is logical equivalent. In the sense that whenever the left hand side of the equation is true, also the right hand side of the equation is also true. In the same vein, whenever the right hand side of the equation is false, also the left side of the equation is also false. So that it is logical equivalent, and that means it is law. Now, since it is logical equivalent, we can also transform it to biconditional statement, and it will still retains the logical equivalent. If and only if P and T, if and only if P. We have now transformed it to biconditional statement, and you see that whenever the left equivalent is true, also the right equivalent is also true. In the same vein, whenever the right equivalent is false, also the left equivalent is also false. Whenever we want to read the statement, the definition of getting falsity always truth. The definition of getting falsity in the statement, whenever I read it, we always get truth. So, and if that is the case, that the statement is tautology. Is tautology. Statement is tautology. Being justified by logical equivalent. Why by logical equivalent? If and only if, since statement is tautology, we can also transform it to conditional statement, and it will still preserve tautology. That is P and T implies P. You have now transformed it to conditional statement, and whenever the antecedent is true, also the consequence must also be true. And if that is the case, if you break the statement, the opposite of getting falsity always truth. You say that the statement is tautology. is tautology. Being justified by logical implication. Biological implication. Now, since this statement is tautology, that means P and T implies P is tautology. We then deduce that it is certain that P and T exist because P and T is a proper implication of P. That means antecedent is proper implication of the consequent. Since P and T exist, certain that it exists, due to P and T is proper implication of P, we then say that P and T is logical implication of P, I mean the consequent. If and only if P and T is logical implication of P. Is logical implication of P. See, this is true that P and T is logical implication of P. Also, this must also be true if and only if P and T is equal to P and T. That means P and T, the logical implication is equal to itself. That means P and T is equal to P and T. And it is true that P and T is equal to P and T because they are logical equivalent. In the sense that whenever P and T are the left side equation is true, also P and T are the right side equation is also true. In the same way, whenever P and T are the right side equation is false, also P and T are the left side equation is also false. So that it is logical equivalent. So it is true that P and T is equal to P and T, being justified by identity, I mean the sameness. Being justified by identity. Since this is true, it's also true. P and T is equal to P and bracket, not P or P. That to say, P and T is equal to not is equal to P and bracket, not P or P. Now we see that this T is being substituted with not P or P, not P or P by law of complement. Because law of complement, not P or P is equal to T. So being justified by law of complement. If and only if and only if P and T is equal to, now this P and the bracket, not P or P, is setting as P and P is equal to P and P by the second Eddy case law is equal to P and P. P and P. Being justified by second Ejike's law. Second Ejike's law. If and only if P and T is equal to P. So P and T is equal to P by law of idempotent. By law of idempotent. We have now proved that P and T is equal to P. We have now proved that P and T is equal to P. We then conclude, say thus P and T is equal to P. Having proved that P and T is equal to P, since the statement is law, that means logical equivalent, we are going to prove the converse. So by the principle of essentiality, we then establish that P and T is equal to P. That means P and T equal to P is law of identity by conjunctive statement. See? Conversely, P is equal to P and T. P is equal to P and T. We have seen that this P and T are the letters equation here has now become P and T are the letters equation here. P and the letters equation here has now become P and the letters equation here. So it is the converse. So let's prove the converse. Say suppose P is equal to P and T. We assume that P is equal to P and T is true and is logical equivalent, because whenever the latest equation is true, also the latest equation is also true. In the same way, whenever the right equation is false, also the latest equation is also false. We say that it is logical equivalent. Since it's logical equivalent, we can also transform it to biconditional statement, and it will still preserve logical equivalence. If and only if P and T. We have now transformed it to biconditional statement. P if and only if P and T. And you observe that whenever the left equivalent is true, also the right equivalent is also true. In the same vein, whenever the right equivalent is false, also the left equivalent is also false. So whenever you want to write the statement, the way of getting falsity always truth. So that the statement is tautology. Is tautology. Being justified by logical equivalent. Being justified by logical equivalent. We continue to this side. So if and only if, since this statement, this equation statement is tautology, we can also transform it to conditional statement and it will still preserve tautology. That means P implies P and T. Then this, you have now transformed it to conditional statements, and whenever the antecedent is true, also the consequence must also be true. So when you want to make this statement, the best way of getting force in this statement always true. To say that statement is tautology. Is tautology being justified by logical implication? By logical implication. So if and only if, since this statement is tautology, that means P implies P and T is tautology, we then deduce that it is certain that P exists. That means the antecedent exists. Because antecedent is proper implication of the consequent. You say that it is certain that P exists. And you say that P exists, we then say that P is logical implication of P and T, I mean the consequent. P is logical implication of P and T. So we have now deduced that P is logical implication of P and T. See, this is true, also this must also be true. So if and only if P is equal to P, that means the logical implication is equal to itself. It is true that logical implication is equal to itself. Because whenever the left answer equation, that's P equal to P, whenever the left answer equation is true, also the left answer equation is also true. In the same vein, whenever the answer equation is false, also the answer equation is also false. Say the logical equivalent. So it is true that P is equal to P. Being justified by identity, that means the sameness. Being justified by identity. If and only if P is equal to P and P. So this P is equal to P and P by law of idempotency. So you substitute P to spell P with P and P by law of idempotency. P is equal to P and P. By law of idempotency. If and only if P is equal to P and bracket not P or P. So P and P is equal to P and bracket not P or P. By second etiquette law, P and P is equal to P and bracket not P or P. by second eject's law. So you can see that you associate this P and P with P and bracket, not P or P. You justify by second eject's law. By second eject's law. Because of this side, if and only if P is equal to P and you see that this not P or P is equal to T by law of complement. This not P or P is equal to T. Being justified by law of complement. We have now proved the converse. We have now proved the converse. That means P is equal to P and the T. That is the converse. We then conclude. Thus, P is equal to P and the T. Since we have proved the converse by the principle of essentiality, we then establish that P and T is equal to P is law of identity by conjunctive statement. Therefore, P and T is equal to P. We have now proved that P and T is equal to P is law of identity by conjunctive statement. So it is true that P and T equal to P is law of identity by conjunctive statement. So at this juncture, we will draw our curtain. Thank you, viewers.